Welcome to the DIY Honda Garage channel. The DTC P0365, which stands for CMP Sensor B Circuit No Signal, indicates a problem in the camshaft position sensor's communication with the Powertrain Control Module, PCM. This specific DTC is crucial for engine performance as it directly involves the timing and synchronization of various engine components. When the PCM fails to receive a signal from the CMP sensor B, it can lead to issues in ignition timing and fuel delivery. The CMP sensor, integral in determining the camshaft's position, is generally located near the engine's camshaft and functions by sending a signal to the PCM to help create an accurate model of engine timing. Understanding this DTC is essential for maintaining optimal engine operation in the Honda CRV models from 2011 to 2016. The error code P0365 specifically refers to a malfunction in the CMP sensor B circuit, which sends critical timing information to the PCM. The CMP sensor B is a vital component in monitoring the camshaft's position, allowing the PCM to adjust various engine parameters accordingly. When this sensor fails to communicate properly, it can create significant issues in engine performance, as the PCM relies on this data to optimize fuel injection and ignition timing. The CMP sensor B is typically mounted on the engine near the camshaft, making it relatively accessible for troubleshooting. Understanding this component's role and location is essential for effective diagnosis and repair. Several factors may contribute to triggering DTC P0365. An open circuit in the wiring can disrupt the flow of information from the CMP sensor B to the PCM, leading to a no-signal condition. Additionally, a faulty CMP sensor itself may be unable to produce a clear signal due to internal failures. Poor connections, whether from corrosion, loose terminals, or damaged wires, can also lead to the failure of the circuit. Each of these causes must be thoroughly investigated during the troubleshooting process to ensure accurate diagnostics and repairs. It's critical to address these elements in order to prevent further engine performance issues. When the DTC P0365 is active, various symptoms can manifest, impacting the vehicle's overall performance. One of the most common symptoms is engine misfires, which occur when the timing of the fuel injection and ignition is disrupted. This can lead to reduced engine power and difficulty in acceleration as the engine struggles to maintain optimal performance. Additionally, drivers may experience difficulty starting the vehicle, especially if the PCM cannot properly manage engine timing. Recognizing these symptoms is vital, as they indicate that the issue is not just a code on the dashboard, but a potential threat to engine health and drivability. The first step in troubleshooting DTC P0365 involves verifying the problem through initial checks. Start by turning the ignition switch to the on position, which powers the vehicle's electrical systems without starting the engine. Then, using the Honda Diagnostic System, HDS, clear any existing diagnostic trouble codes. Following this, start the engine to see if the DTC reappears. This step is crucial, as it allows the technician to confirm whether the fault is persistent or intermittent. If DTC P0365 appears again, it confirms the failure, necessitating deeper investigation into the sensor and its associated wiring. For the second troubleshooting step, begin by turning the ignition switch to the lock position to ensure safety while working on electrical connections. Next, disconnect the CMP sensor B3P connector to facilitate checks without interference from the sensor. With the connector disconnected, turn the ignition switch back to the on position. Use a multimeter to measure the voltage between test points identified in the diagnostic procedure. Specifically, Check for battery voltage at the respective test points, which include the CMP sensor B connector's yellow wire and body ground. If there is no voltage detected, it indicates an open circuit in the wiring leading to the sensor, thus prompting necessary repairs. In step 3, the technician should again measure the voltage, but this time the focus will be on identifying the TDC line. Keeping the CMP sensor B connector disconnected, the technician measures the voltage between the green wire of the CMP sensor connector and body ground. It is crucial to check that the voltage reads approximately 5.0 volts, as this indicates that the TDC line is intact and functioning properly. Should this check show an abnormal voltage, further investigation is warranted to determine the exact point of failure in the wire connection. The outcome of this test will guide the next steps in the troubleshooting process. Step 4 involves another voltage measurement, this time focusing on the LG2 line of the CMP sensor wiring. Ensure that the CMP sensor B connector remains disconnected, and measure the voltage between the yellow and brown wires of the connector. Confirm that there is battery voltage present. This is critical for confirming the integrity of the wiring. If consistent voltage is detected, proceed to replace the CMP sensor B, as this indicates that the wire lines are operational. If no voltage is present, an open condition exists in the LG2 wire, which requires locating and repairing the break in the wire between CMP sensor B and ground junction G101. In this 5th step, safety precautions require turning the ignition switch to the lock position again. Before proceeding, the SCS line needs to be jumped with HDS to avoid any inadvertent errors during diagnostics. Then, carefully disconnect the PCM connector C and CMP sensor B connector. This setup allows for a continuity test between the respective green wire pin from the PCM connector and body ground. Should continuity be detected, it confirms a short in the TDC wire connecting the PCM and CMP sensor B, which necessitates immediate repair. However, if no continuity is present, the TDC wire is not shorted and other troubleshooting steps may need to be undertaken. The 6th and final troubleshooting step involves performing a continuity check on the TDC line to ensure all connections are intact. With both the CMP sensor B and PCM connectors still disconnected, test for continuity between the green wire of the PCM and the green wire of the CMP sensor B connector. If continuity exists, it indicates that both wires are intact, allowing for possible updates to the PCM software version or substituting it with a known good PCM, thereby confirming proper function. If continuity fails to register, this signals an open circuit that requires immediate attention and repair. Ensuring these elements are accurate is part of thorough diagnostics and essential for resolving the DTC. After repairs are made, the final repair verification process is crucial for ensuring that the DTC P0365 has been adequately addressed. Start by turning the ignition switch to the lock position. Then, carefully reconnect all disconnected connectors, ensuring there are no loose terminals or faulty connections. With connections re-established, utilize the HDS to reset the PCM, which allows the system to refresh its data and recalibrate as necessary. Following this, perform the PCM idle learn procedure to enable the engine to adapt its idle parameters based on new conditions. Finally, check for any pending or confirmed DTCs within the HDS. This is a critical step to confirm that no further issues exist. Preventive maintenance is vital in avoiding the recurrence of DTC P0365 and ensuring the longevity of engine performance. Regularly inspecting wiring for wear and tear can mitigate issues caused by open circuits or shorts. It's essential to check sensor connections periodically, as corrosion or loose terminals can lead to communication failures between sensors and the PCM. Keeping the vehicle's software updated ensures that the PCM operates with the latest improvements and features, which can enhance performance and reduce the likelihood of errors. By engaging in these practices, vehicle integrity can be optimized, thereby preventing DTC issues from arising in the future. Understanding the nuances of DTC P0365 is critical for effective vehicle maintenance and repair. Recognizing the role of the CMP sensor B, alongside familiarizing oneself with its location and connections, is key to promptly addressing issues. Identifying symptoms early helps prevent potential engine problems that could arise from the improper timing and fuel delivery associated with this DTC. Following the systematic troubleshooting steps ensures that any wiring issues or sensor faults are accurately diagnosed and repaired. Ultimately, a proactive approach to vehicle maintenance not only resolves immediate concerns, but also promotes long-term engine health and reliability. Please like and subscribe to the channel. See you next time.